Let's look into some problems, some examples, problems based on parallel lines and its angles. So we have learned all different types of angles from parallel lines and a transversal line. So there were corresponding angles, alternate interior angles, alternate exterior angles, and co-interior angles. Sum of co-interior angles is equals to 180. So now looking at this diagram, it says it's given that ABC are parallel and D is the transversal line, as we can see. So you have to find out all the angles. Just use those angles made by parallel lines with the transversal line. You should be able to find all of them. So according to this, that particular angle is 60. There are different ways to do this. Let's see. I'll mix and match, so you should be able to find out all other angles. If A and B are parallel, what are the two angles which are going to be corresponding? 2, 2 and that 60. So corresponding angles, I'll write them separate so you will know exactly. Exterior, alternate exterior angles and alternate interior angles. Co-interior angles, we'll come back to this at the end just for verification purpose. Corresponding angles, what are the corresponding angles? Let's just write it out. Angle 2 and that angle 60 degree, sorry, not angle, that is just a 60 degree, angle 9. These are all corresponding angles because there are three parallel lines. If it was given A and B, only 2 and 60 are corresponding, so I would have written angle 2 is 60. But now if I take only B and C, that 60 is also corresponding to angle 9. So all of them are going to be equals to 60 degrees. So now let's take a simple method. If this is 60 and 5, what would have happened? If I take 5 plus 60, if I take this as x, so x plus 60, B is a line which is a straight line, angle at that particular point, straight angle 180 degrees. So x plus 60 is actually going to be 180 degrees. 60. So x will be equals to 180 minus 60, which is equals to 120. So angle 5 is 120. Let's just keep that in mind. Keep it aside for now. So now this is 150. We based this on either linear pair. Remember, sum of angles, if it is a linear pair, those two sum is actually going to be 180, or otherwise right angle is 180. So we considered this as linear pair and then added them, substitute that to 180. We found out the value of that x, which is the angle 5, which is equals to 120. Now going back to parallel line properties, 5, 1 and 8, all of them are corresponding again. 1 is supposed to be equals to angle 5, supposed to be equals to angle 8, because they are all corresponding angles, so all equals to 120. So what did we find out now? For now we found out angle 5 is done, that we already knew, that we know, that is done, that is done, that's done. We used only corresponding angles. Now let's go back to alternate interior angles. So we know 60 alternate interior. For A and B line, the interior area is only that. This is the only interior area for, that is the only interior area for A and B. Exterior area is outside here, and exterior area for B and C is this side. So let's just assume that C is not there. Exterior for AB will be outside this and outside the B. So let's just take A and B and let's go with alternate interior angles. Interior, these are 3, 4, 5 and that 60 is interior. So alternate is 3 and 60, so that means automatically what happens? Automatically angle 3 is equals to be 60, alternate interior angles. 5, angle 5 we have already calculated that as 120. The interior, alternate interior of 5 is 4, so that means angle 4 is equals to 120. Why am I substituting values of all this? These are based on properties or the angles made by transversal on parallel lines. So because they are equal, corresponding angles are equal, alternate angles are equal, alternate interior and exterior angles are equal, and sum of co-interior angles are equals to 180. Let's go with that. So now 8, here we have written 8 as 120. If this is 120 for B and C, and for angle 8, angle 7 is alternate interior. So 9, already we took it as 60, one of the corresponding angles. If this is 60, alternate interior for 9 is 6, which is that 60. So what happens? Alternate interior angles, angle 6 equals to angle 9 equals to 60, and angle 7 equals to angle 8 equals to 120. Coming back to same thing again, different ways of doing this. So let's just take corresponding angles itself. 10, 6 and 3 are corresponding angles. 11, 7 and 4 are corresponding angles. We know 7 is 120, so corresponding angle, this should be 120, that should be 120, and we know that interior angle, what is that, angle 6 is 60, and then 10 is corresponding, 6 is corresponding, 3 is corresponding. So I'll just write it here. Angle 3 equals to angle 6 equals to angle 10 equals to 60, corresponding angles. Similarly, angle 4 equals to angle 7 equals to angle 11 equals to 120. So now what happened to exterior angles? Let's just take this one. Angle 1, here if you see angle 1 is 120, so I'll write it here just for reference. Angle 2 is 60, okay, corresponding angle. So if I take only A and B line, exterior angle, so for A and B line, in between this line is all interior, anything outside is exterior. So exterior 1, 2, 6, 7 are exterior angles. So alternate exterior will be 1 and 7, 2 and 6. As you can see, 1 and 7, they are already equal. So angle 1 equals to angle 7 equals to 120. You could have also used alternate exterior angles to find out. Once you found out 1, you can straight away put it as equals to 7 and write the reason as alternate exterior angles. Similarly, 2 and 6. Same thing goes with if I just consider only B and C. Only B and C. Only B and C. If I take the area between B and C is actually interior, anything outside is exterior. So angle 5 and angle 11, they are alternate exterior. Angle that 60 and this 10, they are 60. So let's take, instead of B, only consider an A and B line, A and C line. B, just think that B is not there. So now if I come back, that is A, that is C. If I see this, here I have 120, here I have 60, and if I take these two, this will be alternate, that should be 120. As you can see, that is 120 there. And if this is 60 and this is 60, anyways you compare with the properties and the angles made with the transversal line on parallel lines, you will still find the same values. So let's say another thing, if when I found out this 60, let's say this was not there, I can still assume this as a linear pair. 60, 180 minus 60, I'll still get it as 120. So as you can see, you can take any two parallel lines, write the angles, use different types of angles made by parallel lines with the transversal, then you will be able to find the needed angle. Let's go back to this co-interior angles. 6, 7 and 9. Let's take just 7 and 9. We knew from the corresponding angle, what we did is we took this as 60. Condition says if they are parallel lines, sum of co-interior angles on only one side, which is that side. 7 and 9, sum of co-interior angles, which is angle 7 plus angle 9, is equals to 180. That's a condition. So because 9 we found it out as 60 by using corresponding angles, angle 7, if we use this method, angle 7 will still be equals to 180 minus 60 equals to 120. Still the same. That is still the same. That is actually going to be 120. Either use this, use this, use this, or use this. You can use vice versa. So you can actually go backwards and say that these two lines are parallel based on the angles given, or otherwise find the angles based on all the angles made by parallel lines with the transversal line.